Okay, we're going to start with an integer a and a positive integer d. We'll say that d divides a if there's some integer k so that a is equal to d times k. So we might say that d is a divisor of a, or d is a factor of a is a multiple of d. These are ideas we've encountered before. And we have a handy notation for this. As a shorthand, instead of writing d divides a, we'll write d with a vertical bar and then a. So d divides a is how we say that. So examples would include 13 divides 39, because 39 is a multiple of 13, or it's 13 times an integer 3. We've got 4 divides negative 20. 5 does not divide 16. There's no integer k such that 16 would be 5 times k. And 2 would divide any integer of the form 8m plus 6. And to see that, we would just note that 8m plus 6 is equal to 2 times 4m plus 3, and 4m plus 3 is going to be an integer whenever m is. So the first result here is called the divisor lemma. We'll let a, b, and d be integers, with d greater than 0. So if d divides both a and b, then it will divide their sum. And that kind of makes sense if we could factor a d out from a plus b. Same thing with their difference. If d divides both a and b, then it will divide their difference. And if d divides both a and b, it will divide any linear combination of them. So ma plus nb, we can factor a d out of that expression. Part 4, if d divides a, then m divides a for any divisor m of d. So divisors of d will also be divisors of a if d divides a. And finally, if m divides d and d divides a, then m divides a. It's kind of a restatement of part 4. Alright, so we're going to prove just part 4 in this case. So we'll write down our assumptions, the things we assume. So we're going to assume that d divides a and that m divides d. So then, in that case, we write out exactly what those two statements mean. So if d divides a means that a is some multiple of d. So we write that a is equal to d times k for some integer k. D is equal to m times l for some integer l. So we've written out the definition of those terms. Then, since we want to show that m divides a, we start with a, and we want to write it as a multiple of m. So a is equal to d times k. We'll replace d with something that's equal to it, which was ml. And then, after a little regrouping, we have written a is equal to m times lk. A is a multiple of m, so m is a divisor of a.